Thanks for bearing with me as the last speech for this whole conference. But you can relax a little bit. So we had very nice presentations. Mine will be more on the story side. Our story, actually, what we did, how we did, and why we did it. And I have to be a little bit careful because as I look through, I have two of my ex-bosses in the audience, so not to discuss the past in details. But redesigning performance verification in Nokia. So first of all, what do we mean in performance verification in Nokia? We have the traditional measurements and validation tests like stability, linearity, capacity testing, and of course we have the more aggressive testing in overload, provocative, and robustness testing. These are the typical test cases that we still, up to today, we execute. With this, we had quite many of the problems, as you will see if it's jumping forward. Yep. So first and foremost, we had a problem in our products. We are a telco provider. You know, or some of you who are in telco, the others can imagine that telco, especially the network side, is rooted back in 80s, early 90s. So we have the software design of the 80s and early 90s. We have an awful spaghetti code base, very hard to work with. As a telco provider, we follow very much the waterfall approach, which is not famous for the very fast feedback time, very fast cycle times. And especially in performance verification, we used to have these so-called reference setups, when some of the product managers and architects designed how the system should look like, what should be the capacity of the system. It was big, bulky, hard to maintain, hard to configure. On top of that, we had this so-called traffic profile, and the traffic profile supposed to describe what is the average usage of the network that we are testing. Quite many call scenarios, 20-something call scenario, messaging, registrations, and so on, whatever millions of calls, whatever millions of SMS. To make life more difficult, for this, we had a very low level of automation, especially in deployment and configuration. In testing, I would say the automation was quite good, but based on the previous 2 points, on the complexity of the system and complexity of the traffic profile, the test result analytics, that was just a nightmare. So we had hundreds of megabytes of plain text measurements at the end. We had Excel files with 60-something sheets, and all these had to be analyzed manually. To go along with our very outdated product architecture, we had a very outdated test automation framework. Again, legacy code base, very hard to reproduce and hard to maintain. And in the products, we had very few testability features. All this resulted in a very slow feedback time to the developers. Basically, Basically, our feedback time to the development was somewhere in the weeks or even months region. And that's not ideal. By this point, and I hope you can see also from this list that we had very much the reason to change how we operate, how we do testing, what is the automation that we use. And lucky for that came the architecture change in our product. Oh, sorry, I forgot I had this slide. So, back a little bit. Based on these products, we had one very huge problem from management perspective. This is mainly from management perspective. Just to consider these ups and downs in the workload. So meaning when the testing, the performance verification was actually ongoing with full speed, we spent all our overtime budget. The yearly overtime budget was spent sometime in the summer. Other than that, when the development of the upcoming release was ongoing here, the performance testers didn't really have much to do. Frankly, they were bored out of their minds. So then came the product architecture change. When from that spaghetti code base, from that intertwining, interlinked product blocks, we went to this let's say, containerized microservice architecture with the concept of reusable building blocks, utilizing so many open source elements like Elasticsearch, Logstash, Kafka, and so on and so forth, that are available off the shelf, and they are now built into our products. And then came the question that how do we do testing on these new products? For that, first and foremost, we took a look on our testing manifesto coined by Szilárd Szél, our very own testing coach in Nokia, which says that we test only if necessary. So if no change regarding performance, why do execute performance tests? What is needed to be executed? We proactively aim to test on the lowest possible test level. Why do we execute performance tests? Why do we execute these huge bulky tests when we could do it on functional test level? Or end-to-end, or whatever. Heavy shift-left activity needed to be introduced. We test on generic cloud hardware and use reference hardware only in limited cases. Meaning that the reference architecture that the product management and the architecture dreamed of, we basically only use for now the validation of the software, that with this blueprint we are capable of this and that kind of capacity. We are able to handle these situations that we provide in our blueprint. Other than that, anyway we cannot keep up with our customers. If we are going to cloud, they can buy any type of hardware, they can use any type of cloud. We just need to keep up with that, which with so many reference architecture cannot be done anyway. And as the last point in the manifesto, we make the risks remaining in the tested product system transparent. Something that I would like all of you to take with, because I've seen the practice, not just in Nokia, but in other companies, that we test till it's for free. Who is for free here? Who says that his software is for free? Nobody, but still I have seen examples that everybody is stating that we tested everything. No, you didn't. We didn't either. So we need to be transparent on this. So we came up with these goals, how we want to change our testing. What should be the main drivers behind any activity that we carry out? First, we need to decrease the lead time of testing. Lead time of testing, configuration, deployment, setting up the automation framework, and so on and so forth. Months and months of activity previously. We have to decrease it. We have to decrease it to within a day. Decrease test case complexity. As I said previously, we had these huge bulky test cases running on these huge traffic profiles. One test case took somewhere between 4.5 hours to over 24 hours to execute. We had so many actions ongoing inside one test case. And we had these huge reports at the end. Too many Excel sheets, too many measurement files, too many information, not analyzable by machine. People need to work on that. Provide fast feedback. How fast should the feedback be? R&D was easy. R&D said that I need the information in 2 hours. Can we do that? Can we be, okay, not 2 hours, but can we be within a day? And automate everything that is done more than once. These were the 4 goals that we put in front of ourselves that we have to comply with. So what we started to do, we had to start redesigning our test cases. Designing by defining the minimum viable unit in both the test case itself, the deployment, and the configuration. So we took the new product architecture that we don't have the spaghetti code anymore. We have microservices. We have containerization. So why do I need to make the load tests on the full system all the time? Why can't I load single containers? Why can't I load single interface? So we took apart all our test cases and designed them to be the minimum valuable unit. 1 container, if it's necessary, or 2 containers, but not anymore. The huge bulky test cases will remain for the very end, for the actual validation of the software that we are capable to deliver, that we promised in the blueprint. Minimum in deployment. Again, coming parallel with test cases, why do I need to build up a system that spans across 8 HP blades? It's way too big. I don't need that. Why do I need to build a whole car to measure the performance of the tire? I don't. So deploy as little system as possible and scale up always, not as we did previously when we had the whole system and scaled down for the problems. Configuration, that awful traffic profile we had. Does it make sense to always have the very big traffic profile? Will the 22 call scenarios make any difference for me if I just load one interface? Will the 22 call scenarios make difference for me if I want to load test the database? No sense at all, so why to build it? Build only what is necessary. Configure what is only necessary. Still, the existing test cases, by the design of nature, were pretty much meaningful, but we had to take them apart in order to comply with our goals and follow these 3 items in the minimum set. So what we did was following the simple rule of deconstruct, stabilize, standardize, automate. The key driver for that was the keyword-driven testing. By keyword-driven, we identified with the robot framework, and we simply started to take apart our test cases, that what are the steps that we execute. We start the test case, we configure, we start the test case, we collect some data, we execute something, we collect some more data, we stop the test case, we analyze. Let's take these apart. What are the commonalities between the test cases? Previously, this was basically undoable. None of our test automation was reusable. We had very well-defined test cases going pages and pages. I tried to put there actually one test case into my slides, but it was unreadable, so about 5 or 6 A4 pages long. Bit crazy, I would say. So how to reuse it? How to build the system based on keywords? Sorry. Is there some water somewhere? So what are the common elements in all the test cases that we had to build? And in order to comply with that, we built some automation systems that I would walk through here a little bit. First, to comply with the R&D's requirement of getting fast feedback and how to make our systems fast, actually. So we had the goal in mind, how should it look like? And actually we are almost here. Only one step is missing, but I didn't put that on the slide. So what we had in mind and started to implement is, I would like to deploy my minimum systems whenever I need them, with whatever configuration I need to execute whatever test case I want. So inside R&D, we have 2 Jenkins parallel ongoing. One is for the infrastructure layer and one is for the actual application code. And in order to, let's say, make a difference from the previous performance verification that we have had, or still have, we created this very artificial category of PST as product system testing, which is not really existing and it's not really meaningful, but we want to designate anyway. So we build a system with this automated environment deployment where we can make on-demand deployments. For this, one of the starting keyword is that I want to have whatever test case. And the second keyword is I want to have configuration on the system, and the configuration is designed into the test cases themselves. So the Jenkins triggers this deployment system, which in return deploys for me the system under test and all the supporting environments, and notifies the test automation system that I'm ready for testing with the required definition of the system. So in return, robot starts the execution of the test cases, collects all the data, make the analysis for the test cases and pass it back, the result to the master Jenkins. Again, the deployment system is notified, which simply clears up after itself. And we have, again, empty clouds. We can deploy whatever we want with whatever configuration we want. And in order to further comply with the R&D's request to have the fast feedback, to go to the direction of continuous whatever, integration, delivery, deployment, name it. We started to integrate with their CI pipeline in the manner that R&D had its own internal after code commit triggering static tests, unit tests, and so on. We create the packages, we push it to the functional testing, and to have it inside still the CI pipeline, we put here the deployment. We put here the test case execution. So we were able to build performance verification into the 2-hour time slot that we got from R&D. Of course, it's not the performance verification that is expected all the time, not the validation of the software. That still requires time. We still have the long execution. We have still 24 hours to execute for a couple of test cases. But in 2 hours, we were able to give the R&D feedback on how its code behaving under load situation. Some numbers about the changes that we reached eventually. Previously, we had roughly around 150 test cases. Last time I checked in the test management system, it was over 400. Nowadays, I believe it's way more than that. The average execution time for one test case in the previous world, when everything was happening the crazy way it did, the test case execution time was somewhere a bit above 4 hours. Now, with the minimum test cases on minimum configuration against the minimum requirement, it's less than 1. Less than 1 to give feedback to the R&D, and it's not just in minutes because we still have some long test cases for the robustness, for example. With the design of minimum systems and minimum configuration on the available cloud space that we have, we previously were able to deploy 12 systems at once. Now, against the requirements, we are able to average somewhere around 70 systems. And in return, with these test cases and these test case times and the number of systems, we reduced the turnover time from 2 months to less than a week. Now, with the decreased test case number, a bit above a week. In return, it had some effect also on the workload. We still have a little bit of a curve. It's not that flat as it should be, but at least now we are not spending the overtime budget. I can't recall if during this summer we paid any overtime, actually, which is, I believe, quite good news, especially for the engineers, rightfully. But they don't have that downtime. They don't have that downtime when they are just sitting and waiting for the day to end and go home finally. So as I said, this was our story. Why and how we try to do couple of renewal actions. Unfortunately, my time slot is not very long, so I couldn't go into too much details. But as you know, the saying goes that the wise man learns from others' mistake. We weren't that wise, so we had quite many mistakes. I would give you a couple of items that I would say something that should be taken home if it's not already applicable to you, and I'm hoping that already applicable. First, keep the testing always to the lowest possible level with the smallest possible increment. Avoid complex test cases at all costs. It's the best. So having complex test cases will just kill your speed, kill your process, and eventually will kill your engineers, because manual work is always needed, and it's simply mind-numbing to go through 100 megabytes of ASCII test. Apply reusable automation, keyword-driven testing. I'm a fan of that. I just became a fan of that, actually. We were quite satisfied with what we had, but it was simply unsustainable and couldn't scale. So reusable automation is the key to scalability of your test automation system and your testing system as a whole. And first and foremost, shorten feedback time. Shorten feedback time to your R&D to be able to not go in circles. Not go in circles in the time that, okay, I wrote the code, yeah, really, but I can't remember what I wrote. It was 6 months ago. You have to have the short feedback time. And this was our story, so if there are any questions.
All right, the first one. How to define fast feedback in case of the example 1 week long stability test? Linux-based systems needs even days to stabilize memory.
Fast feedback doesn't necessarily mean that you have to give fast feedback on everything. You have to provide a fast feedback that the code is working, it's well behaving under load situation. As I said, you will have long test cases. You simply cannot avoid that. But having only long test cases, that will kill you. So 1 week long stubby, yes. Linux-based systems, yes. And let me tell you, Telco, even worse than Linux-based system. But there are, and I would say, and with a visible amount of money, I would bet that 80% of your test cases you could shorten.
Okay, the next one. When you exclude the environment, the integration will not be tested, or?
Why not? Why not? If I want to test the tire for performance, do I need the whole car? I didn't say that you don't need to build the whole car. You have to build the whole car, but you will build the whole car to test the whole car. To test the tire, you just need the tire. Integration testing is a must, definitely. But before you integrate, or let me give you another example, let's call bridges. Will you build a bridge and send over 200 people before you find out what one single screw can take? I'm hoping not. Because if you just found out that that screw can take 200 people, then the bridge will collapse and the 200 people will fall. So start with the small one and scale up if you need it.
Okay, and the last one. Do you track trends of performance measurements? Do you use trend graphs? If yes, what technology would you suggest?
Not really. We don't really track the trends of performance measurements. We have different KPIs we have to comply with, and we simply don't keep track from release to release how it will change. By the architecture team, it is somehow tracked, but I wouldn't say that they have any graph for that, or they have an Excel sheet for that, so they can draw a graph if needed. But other than that, we are just complying with predefined KPIs.
All right, so we are out of time. Thank you so much again. And
let me ask one more question.
Okay.
How much extra effort was to get starting working this way? Because this is a key question, especially from management perspective. Basically, I spent 6 months on convincing my manager that this is something we need. Then finally he gave in and got 2 guys in end of October and told them that you have to deliver the first working prototype by Christmas. And they did. So I would say effort, there are some. The main effort here is to actually define the test cases. The automation part is very much deliverable, even for complex system. The test case design and what you test and why you test, that is something that you will spend much more effort on.